Hello, this is Yakov Fein with Farata Systems. Today is lesson number 16 in the Intro to Java and Java EE training. Today we'll be going to be talking about Java Naming and Directory Interface, or JNDI, and Java Messaging Service. So what is JNDI? If you remember when we had a lesson on RMI, Remote Method Invocations, we spoke about registry. A place where objects are registered, where services are registered. And JNDI is from the same domain, I would say. It's about storing references to objects. Let's see what it is. JNDI helps your classes, your Java classes, in finding other classes it needs. When you start a Java EE server, it also brings up the so-called JNDI tree with objects that were bound to it. So if your Java class that runs inside of the Java EE container needs an object, it can either look up for this object in that JNDI tree, or it can request something that is called injection. You can declare a variable and the reference to the object will be injected into your variable. How the whole magic happens? Of course, somebody has to bind these objects to JNDI tree, so they are known over there under some names. Who is this something? Whoever is responsible for administration of this Java EE server. Binding can be done using admin console, administrative console, or it can be done using scripts. It depends on the server. In some cases, it's still XML descriptors, but one way or the other, the object should be bound to JNDI tree. What can you bind? From what you already know, if you remember in the lesson on JDBC, when we work with relational database management systems, I told you that driver manager is one way of getting connection to the database, but the preferred way is using so-called data sources. Data source can maintain internally a pool of connections, right? So the data source can be in advance bound to the tree, to the JNDI tree, and then the classes that need this data source will look it up. On the root of the JNDI tree, there is something called initial context. So if you have a reference to the initial context of the tree, you can start searching deep down inside that tree, starting from this initial context. To be accurate, you don't have to start searching from the initial context, but the simplest case is let's start searching from the root. If your class is running inside the Java EE where JNDI tree was created, then you have a choice. Either you can do a lookup of the object in the JNDI, or you can ask for injection. If you declare a variable and you annotate it with @resource, the object that exists in JNDI will be injected into the variable. If you are running a standalone program that needs to connect to Java EE server that has JNDI tree somewhere over there, then you have the only choice is lookup. Get a reference to that remote JNDI and do a lookup. How do you get a reference to the root of the tree, to the initial context? Again, two cases. Case number one, if the program, the class that needs it, is running inside of the Java EE container, then it's very simple. You just say new initial context and you get a reference in your variable to that root of the tree. Your class is running inside the container, JNDI is running inside of the container, all parameters are known. Where is that initial context? But if you are running outside, a program that is outside of the Java EE container, then you have to create an instance of the object properties, fill it out with values, and then create an initial context giving these properties to the constructor of the initial context. How do you know the properties? You have to read the manual. Exactly, you have to read the manual for a particular Java EE server that you are trying to connect to. On this slide, I show you the example of what are the properties that are required to connect to Glassfish JNDI tree. So everything is written in documentation how to do all that. Properties, factory initial, factory URL packages, state, local host, which is over here. You're saying where the Java EE container Glassfish in this case runs, on which port. So all that, when it's done, then you can get a reference to this initial context from any program, even if it's run outside of the container. Administered objects. In this slide, I show you some of the JMS administered objects. I didn't start explaining JMS yet, but just bear with me. Java messaging servers. Java messaging has administered objects such as queues, topics, connection factories, and all these can be bound in advance to JNDI tree, so you can look them up and then send messages over there, or maybe receive messages from there. But we'll talk about it in a couple of minutes. Resource injection. Resource injection is something that you specify with the resource annotation. Resource injection is about injecting classes that are bound or were bound to JNDI tree. Not to be confused with something else. There is so-called CDI in Java context dependency injection. With CDI, you can inject any classes, any object to be precise. But with resource annotation, you can inject only those objects that exist in JNDI tree. In this example, I show you how you can inject the reference to the data source object if you would be working with relational databases, for example. So after these two lines, the variable myDataSource will have a reference to the instance of the data source. After that, you can get a connection to the database and work with it. In this example, you are looking for a connection factory which is used for messaging. Again, it has to be created upfront in the Java naming and directory interface. In this example, you are injecting into a variable test queue a reference to the object that is known in JNDI tree as queueTest. After that, you can send messages over there. That was injection. Lookup of the resources. If you created a reference to the initial context, as we did a couple of slides before, then your variable naming context already knows where it is, and you can start doing a lookup. You're saying a lookup, and then you specify a string that represent the object that was bound to the JNDI tree. In this example, we are trying to find something that is known under the name JMS queueTest in JNDI tree by doing a lookup in the initial context. We know that by this name there should be an object that of type destination. That's why we are doing the appropriate casting over here. After that, you can use this variable destination as if it points to an object that was created with a new operator, even though we don't do this over here. So these are the basics of JNDI. And now let's talk about the second major, actually, topic of today's lesson, Java Messaging Server, or JMS. First of all, let's talk about the terminology. What are these terms that we need to know about? JMS, Java Messaging Service, it's an API. While MOM, Message-Oriented Middleware, it's a specific server that supports messaging. I'm going to use this analogy with DBMS, the Database Management Systems, and JDBC. JDBC is an API to connect to a particular database management server, to DBMS. On the same note, JMS is an API to connect to and work with messaging servers. JMS is a standard API for Java programs, and you can use the same set of classes to connect to different messaging provider. In this slide, I mentioned some of them: EMS, formerly known as TIPCO many years ago, or WebSphere MQ is another messaging server formerly known as MQ Series, ActiveMQ, OpenMQ, Fiorana MQ, Sonic MQ. There are so many different messaging servers, and we'll see why we want them. Another analogy from the real life. Messaging server is in a way similar to a postal service. What do you need to do to send a letter to your friend or to anyone? You write a letter, you put it in the envelope, then you put a postage and you drop it in the mailbox. After that, sometime later, the postman or the mailman will come over, pick up the letters, take them to the post office, then using planes, ships, or maybe cars, it'll deliver the message to the destination point. If the letter is supposed to have guaranteed delivery, then the postman will stop by the apartment or the house at the recipient and knock at the door. Are you there? I got a letter for you. Nobody answer. Then the postman will take the letter back to the post office for storage. Tomorrow maybe he'll try again. You know how this works. So messaging servers function similarly, of course much faster than the snail mail. So these messaging servers can deliver messages and can store messages for future delivery as well. So let's move on and see some specific case, some specific use case. Let's take a look at two major models of messaging. One of them is called point-to-point, and the other one is called pub-sub or publish-subscribe. Point-to-point or P2P is a case when a program message producer sends a message into a queue, places a message into a queue, and there's only one consumer for this message. Another program somewhere else on a different computer, or maybe on this computer, it picks up the message from the queue, and a message can have only one consumer. As opposed to publish-subscribe, when there's one publisher and many subscribers. So one message can be consumed by multiple subscribers. But let's take a look at this use case. Imagine a financial situation, financial application when people are placing trades. They want to buy stocks or sell stocks. Say I have an account with certain brokerage company. I'm sitting somewhere at home on the left from this diagram with, say, web API, web interface. I want to place an order to buy 100 shares of IBM at the market price. So I connect to my brokerage account with this firm, and I place an order using their UI. The brokerage company needs to send this order to the stock exchange for execution. And let's assume that this stock exchange is a different, somewhere remote server, maybe on NASDAQ or New York Stock Exchange, and that server has a messaging API. So our brokerage company can create, again, I assume that we work in Java, even though it doesn't have to be the case. We create message producer. Message producer creates a new instance of a message to send to the stock exchange, but it doesn't send it directly. It sends it to a queue in the message-oriented middleware, messaging server. All these messages are lined up sequentially, and it's first in, first out situation. So if I place a message to buy 100 shares of IBM, it's going to be sitting here in this queue. I assume that the stock exchange has another program up and running that is listening to the queue, that is watching this queue, and as soon as some message arrives to the queue, this message consumer receives it from the queue, dequeues the message. Then they apply their business logic, they make a purchase, or maybe they sell the security as per order, and they need to send back the notification to the user, yes, I purchased for you 100 shares of IBM. Maybe not 100, maybe a partial order was executed. For now, I just bought 75 shares of IBM. So the message producer on this side will push a message into a different queue, right? This queue is about order executions. Again, on the brokerage companies, there should be another program running, listening to this queue about executions. And as soon as the message comes in, this consumer will pick it up and then we'll do some business processing and maybe send the message to the user, dear friend, we bought for you 75 shares of IBM at so-and-so price. Important part to understand is that when the message consumer receives the message from the queue, the message is deleted from the queue. When exactly? Is it immediately when this program received the message, or maybe sometime later? It depends, and we will be talking about message acknowledgement and message transactions a bit later today. PubSub, publish, subscribe, it's a different situation. One producer, or we call it a publisher, say price quote publisher. The stock exchange is publishing prices for the stocks, price quotes. It can publish the quote, now we're going to be using different term, not to a queue, but to a topic. Say there is a topic called price quote topic in the messaging server. And the stock exchange is publishing these messages to the topic. And multiple programs from different users in different locations can subscribe to this topic. So as soon as the message is published, all subscribers, at least those that are active when the message was published, will get it. What if subscriber 1 and 2 were up and running, the programs, and subscriber N or 3 or 4 was not? It was unpowered, down. The user was not around. Will the message be still delivered to the subscriber number N? It depends. If the subscription was set as durable subscription, then these messages, the message will stay inside the message-oriented middleware until all subscribers received it. If we are using non-durable model, then only those subscribers will get the message, only the active subscribers will get the message. Is it fair? Is there a use case for this? Of course. If you are publishing price quotes, for example, what's the big deal if somebody doesn't know that last second the IBM's price was so-and-so? So the next second will be a new price. If somebody missed that price, that's okay. But, of course, there are business cases when you cannot use this model and you must have guaranteed delivery to all subscribers. In cases like this, you'd be setting the durable subscription. What is the preferred way? Durable or non-durable? Take a guess. Of course, non-durable is much faster. Why? Because you don't have to save it on the disk. Everything is happening in memory. Subscriber is not there, that's fine. The message is gone. But not in every situation you can get, you can afford to have non-durable subscription. So both of them have place in life. Next, the API. I want to make sure you see this 1.1. Java Messaging API is a great API. Probably if you will ask me if it's possible, which API in Java you like the most, I would say JMS. Java messaging allows you to build asynchronous or loosely coupled system. Actually, let me get back a couple of slides. Look at this picture again, this diagram. We are not directly connecting brokerage company and stock exchange. We have a middleman over here. So imagine the situation that the stock exchange servers for some reason are down. They were not up, or something happened over there in the middle of the day. But our brokerage company can still receive orders, and these orders will be sent to the message oriented middleware, and the orders will be accumulated as messages in the queue. The queue will be swallowing, so to speak. Till when? Till the stock exchange servers will be again up and running. Asynchronous situation, right? So we loosely coupled. Of course, it's not a good idea to have messages in the queue, accumulated in the queue. Ideally, we should have a well-balanced system that the number of messages that are coming in is roughly the same that are being pulled out of the queue, dequeued. We need to drain the queue in a timely fashion, and of course, when you will be designing or architecting such a system, you will need to see how many consumers you need to create, and maybe they should be in parallel. They should be getting messages from the queue. So let's go back. So JMS 1.1 was released 10 or maybe 12 years ago, and nobody touched the spec. It was great, it was working fine, and only now, this year, in Java EE 7, a new spec of JMS was created, JMS 2.0. I am teaching and showing examples of JMS 2.0 in different courses. We have a course called Modern Web Development for Java Programmers. Over there I go through other examples, but the good part is that JMS 1.1 is still working fine, and there are only 2 servers that support JMS 2.0 so far, Glassfish 4 and JBoss's, actually Red Hat's Wildfly, formerly JBoss. But most other still support 1.1. A bit later I'll have a slide which highlights the differences for that simplified API that exists in Java in JMS 2.0. For now, let's just go through this API, through these classes. In JMS 2.0, you will have to use less steps to send the message or to retrieve a message. So what are the terms? All these blue names are names of the classes from JMS API. If you want to use a program, to write a program that uses these classes, you're going to have jms.jar in the class path of your project to have all these classes. Q is a class. You will instantiate the object Q that's supposed to point at a particular queue where you want to send messages or you want to retrieve messages from. Q connection is a connection to the messaging provider or MMM server. Q connection factory creates connection. Also, you have something called Q session. When the program starts sending messages, it creates a session. When you create a session, you specify the acknowledgement type as well, or if transactions should be supported or not. Okay, then Q sender. It's an object that knows how to send messages to the queue. Q receiver, accordingly, Q receiver knows how to receive messages from the queue. Q sender knows how to send messages. So you will create an instance of a message, give it to the Q sender. By that time, Q sender will already know the queue to send to, and boom, it's going to send it there. Accordingly, Q receiver, the previous steps will be the same. You need Q connection factory, Q connection, point at the queue, and then you will create a Q receiver. It's a different story. It's not a sending, but receiving messages from the queue. If you're going to be using pub/sub model or publish/sub, publish/subscribe, then you're going to be creating similar classes, but not queue, but topic. Topic, publisher, topic, subscriber. Topic is what you want, where you want to send, of course, destination. Topic publisher knows how to publish messages to the topic. topic subscriber, of course you can have multiple of those, know how to subscribe to the messages. And of course message. Message is a type of an object that you can send or receive or publish or subscribe to. As a matter of fact, there are multiple types of the message, and these are the types. They all are subclasses from message. Text message is a simple text. Any text, any string basically can work as a text message. Buy 100 IBM market. Text. Or object message. You can create an instance of any Java object as long as it's serializable, and this instance you can send to the queue. If you're sending Java objects, of course, on the other end of the queue, you're supposed to have the receiver, message receiver that knows how to work with Java. In a general case, you don't have to have Java sender and Java receiver. You may have Java that send messages, and on the other hand, the program written in COBOL or maybe in C that receives messages. But we are talking about Java to Java, so if you are planning to send Java object, then of course somebody needs to know how to deserialize them. Byte messages is just an array of bytes. Stream messages is in a way similar to data input, data output stream. If you remember input output streams, when we learned, you can send a bunch of primitives, send a long, maybe int, long, and so on. So it's a similar situation. And map messages are key value pairs. For example, you can have a key as an ID and the value 1, 2, 3. So you want to send these kind of messages. Now how to send the steps. Again, it's JMS 1.1. You need to create a connection factory object and then say to connection factory, please create for me a connection and start it. Then you create a session object, a queue object, message producer, and create one of these message types that we just discussed. Put some data in that type. In this case, it would be a string, and call the method send. Then you're closing sender, session, and connection object. By the way, in JMS 2.0, you don't have to close it, because if you remember auto-closable interface, try catch auto-closable. In JMS 2.0, you can use this feature, and you don't have to close all these objects. Sending messages, the program, we're going to be running it now in Eclipse in a couple of minutes. This is how it works in action. I want to show you, and I want to stress this little piece. In this case, I show you how an independent standalone program can directly work with a particular messaging server. In our case, we're going to be using so-called OpenMQ messaging server. It's an open source messaging provider, messaging server. Glassfish happened to package it, and so when you install Glassfish, you already have it. You already have this OpenMQ software. But I want to stress, to use messaging servers, you don't have to have Java EE servers as well. And actually today we are not going to be using Glassfish for this setup. An independent program will send the message to OpenMQ server, and the other program will retrieve a message from that server. A bit later, I'll show you still how you can hook up the messaging objects to the JNDI object. At least I'll tell you where to look at. But for now, just look at this. We have specific connection parameters. How do I know about these parameters? I read the documentation. If connection factory would be created up front as administered object, and it would be bound to JNDI tree, the whole thing would be easier. We wouldn't need to know the specifics of a particular MOM provider. But I want to show you the raw case, so to speak, so you know how to do the whole thing from scratch. So creation of the connection factory and starting the connection. Then we create a session with a couple of arguments. First one states if you need transaction support or not, and second, what kind of acknowledgement you want. In a couple of minutes, I'll explain you a bit more details about these. But in JMS 2.0, this is a little bit simplifies this API. If you want transaction or you want just acknowledgement. Then you create a queue that points at a particular queue. This queue test under this name is supposed to be created up front in the messaging server by MOM admin. Whoever is admin is supposed to create this messaging server. Now, message producer says create producer for this particular queue, for the test queue. Then you create a text message in this case with this content, IBM 200 market, and you send it out. So this message will go directly to the test queue. Over here you have a catch clause to catch JMS exception, and then finally in JMS 1.1 you have to close all these objects. By the way, in JMS 1.1 you have to use JMS exception. In JMS 2.0 this is kind of, they go easier on you. You don't have to use catch JMS exception anymore. How to receive a message? Again, JMS 1.1 way. Two cases. Case number one, synchronous. Case number two, asynchronous. Of course, we prefer asynchronous way. The asynchronous is a callback on that you register message listener and you say which class or which object implements message listener interface. And if you say that it's implement message listener interface, it means that in that class you wrote implementation for the onMessage callback. So whenever message arrives to the queue, that onMessage callback will be invoked, and your business logic will go there. The synchronous way of receiving messages is this: queueReceiver.receive. Instead of specifying a callback, you just block on the queue and just wait. Honestly, I'm using this for many years. I don't remember if I ever used received. Maybe I used it for an example, but not for the real world application. Most likely you're going to be creating message listener with that implements the callback. So how the receiving part works? You need to get a connection factory. Again, either create it from scratch or get it from JNDI tree. Then connection factory will create a connection. Then connection will create your session. Then you will point at the queue, particular queue. Then the queue receiver will get ready to get messages. And if it implements message listener, your callback will be invoked. Otherwise, you can just block on the queue and just say, give me the message. At the end, you are closing connection if you are in JMS 1.1. In JMS 2.0, you don't close the connection. Here's an example. In the beginning, you are creating the connection factor and connection. This is the URL where we're going to start the server. We're going to start the OpenMQ server in localhost in port 7677. This protocol MQ, this is specific to OpenMQ. Start the connection, specify that you want to create a session with no transaction support, with auto acknowledge mode of acknowledgement of the messages. Which queue you want to watch, so to speak. Test queue, create consumer, not producer, but consumer in this case, and specify who's going to be listening to the messages. In our case, it's this. It means the same object. The queue receiver will be a listener, which means that it has to implement message listener interface, which means that it has to implement the callback on message. When the callback on message is called, it's going to get the argument of type message, meaning that the message is in the queue. Then you can do whatever you want with the message. In this case, I show you how you can test what type of the message is there. If it's text message, do this. If it's an object message, do that. It's not a typical situation. I just show it to you just for studying purposes. Usually you have a dedicated queue, and you know that in that queue you will always have this particular type of messages. I am kind of rushing through this topic. Usually in that other course I spent 3 hours explaining messages, but in our intro course we have only 1 hour, maybe a little bit more. So I'm trying to be brief. But I hope you're going to be reading the textbook or maybe other books, and I also give a reference to the online tutorials. What are the acknowledgement modes for the message? First of all, let's take care of transactional messaging versus not transactional messaging. What is transactional? Remember, transaction is a logical unit of work, and it's still the same notion over here. Imagine that you want to retrieve a message from a queue and save it in a database. 2 operations, but you want to treat them as one transaction. So say a message was retrieved successfully, but the error happened during saving to the database management system. In this case, if you want it to be transactional, then you will do a rollback. You're saying, no, I don't want it. I want either everything successful or rollback. In this case, the message will go back in the queue. If both operations are fine, then you can explicitly call the commit, and then it's considered done, and the message will be removed from the queue. That's a transaction. If you specify false in the first argument, if you want transaction support or no, when you create a session, then you have to specify the acknowledgement mode. Again, in JMS 2.0, it's API a little bit cleaner. The idea is the same, either transaction or just acknowledgement, but the API is simpler. Auto-acknowledge means that as soon as the retriever class receives the message, then it gets deleted from the queue. You can say, what if the class received the message, but then something happened? It failed. Tough luck. It's auto-acknowledged. If you don't like this, you want to use client acknowledge. What it means that the receiver got the message, then some business logic is applied to the message, and if everything went fine, then the receiver explicitly call the method acknowledge on the message. And this is a command for the MOM server to remove the message from the queue. Duplicate on acknowledge means if duplicates are okay. If the messaging server, maybe there are some problems, failures, and it sent the same message twice, duplicate. Is this okay? Of course, if you're sending a message to buy 100 shares of IBM, of course you don't want duplicate. But if you're sending messages with some price quotes, then it's okay. So this was about sending point-to-point messaging. Pops up, publishing a message, very similar. You create a topic, not a queue, but a topic. I assume that messaging administrators created the topic with this name already. Say you are creating, maybe it's an auction, or maybe it's an actual store, online store, and you want to publish messages about some sales event in the store. So you can create a topic, price drop alert. And then you create a publisher, and then you start the connection, and you create a text message, and you can send this, you can actually publish this message to the topic. Whoever are subscribers for this topic, they will get the message. Very similar. The difference is, again, with PubSub, you can have multiple subscribers for the message. And this is a larger piece of code. Very similar. You specify if the class implements a message listener interface, then on message is a callback. And now we'll try to send a message and receive a message with the OpenMQ messaging server that happened to be packaged with Glassfish, but again, it's regardless. Even if Glassfish was not around, you can still run these programs. In this walkthrough, I am not using anything specific to Glassfish. Let's see where that If I installed Glassfish somewhere, Glassfish 4. In the Glassfish 4 you have all this, and you will find in your installation of Glassfish 4 the subfolder called MQ. That's the guy. That's the OpenMQ software. So what we want to do, we want to open the command window or the terminal if you are on Mac, and we want to get into this folder bin. I'll do it quickly. All right, so we are here. Let me make it a bit larger, font. We are here. Where am I? PWD in Glassfish, ls, MQ, cdmq, ls. We have bin directory, right? cd bin. We have a bunch of different programs in there, and one of them is broker, IMQ broker D, and that's the one that we're going to be starting. That's the messaging server that will start, and will start listening to the messages. On the other hand, we're going to be using the second program that is for administration, and you will see it over here. So the first case, we want to start IMQ broker D. If you're on Windows, you're going to be starting EXE. Otherwise, you're going to be starting this IMQ broker D on Mac. We want to start it on port 7677. This is what I want. At the bottom of this slide, I showed you something to fix a situation if you will run into a special error, unsupported major minor version 5.51.0. It happens when different packages are compiled in different versions of JDK. So if you are on Mac and run into this situation, and most likely I will run into the situation now, then we have to create the Java home and start this broker D, which is the messaging server, OpenMQ with this parameter, and then when we will use admin to create administered objects, such as Q, maybe a topic, then you're going to be also using the same parameter. So first we need to start this broker D, and then we will need to open another command window. And in the second command window, we will start admin console for the OpenMQ. Why do we need that? We want to create a queue, configure administered object queue named test queue. Okay, let's try to do that. So if I will run this IMQ broker D, right? And I want to run it in port 7677. See, I got this error. Unsupported minor major version. So let me fix that. Let me do export. Java home. All right. It's not a valid. What's wrong with that? I forgot to put this equal sign over here. That's why it gave me a problem. Now I will try to start this broker D. But I need to specify this parameter Java home over here. Invalid location. What's wrong with that? Let me redo this again. Yeah, it worked fine. It started. It says that it's ready listening on this port. Now I will create a new window. So that's window I leave alone. And I create a new command window, new terminal window in this case. And what I will do, I will also need to do this export again, copy paste. I don't trust myself anymore. And then I need to start this IMQ admin. Right, so we got this admin console, a simple console that comes with OpenMQ. You have these brokers over here. I already created a stock broker for us. It's a temp one, but I explain you what you need to do over here. You need to, step number 3, right-click on brokers and add a new broker and name it stock broker with port number 7677. If I wouldn't have it, I would right-click, add broker, and I would specify whatever name I want and the port I want. Now, step number 4 in this walkthrough, you need to connect to the stock broker and then add a broker destination named test queue. So, stock broker, right-click, connect to broker. When you are successfully connected to broker, then you go to destination. In my case, I already created test queue, but even you will do from scratch, right-click, add a broker destination, and you will give it a name. Name of the queue, is a queue or it's a topic, and so on, number of messages, and so on. So we are fine with this case. So we created, we started the messaging server, OpenMQ. We went to admin console and created administered object named test queue. That's what we did on this slide. On the next slide, we need to download from the book site. We need to download the lesson 30, right? We already did it many times. And then import it to the Eclipse project, which I already did. Now, one thing I want to show you that you will need to deal with. When you will import that project, lesson 30, that was published in the book site, it's a bit old, of course, it's about 3 years old, and you will need to change the jars that you use, because 3 years ago I've been using Glassfish 3, now it's Glassfish 4. The Java version is different. Right-click on your lesson 30 in Eclipse, go to Properties and Java Build Path. When you will import that project from the website, you will see references to outdated Glassfish 3. You need to remove them, and you're going to see the reference to outdated JRE, which was 1.6 back then. So what you will need to do, you will need to remove those old ones by pressing the button Remove, and you will need to add 2 jar files. They're both located in the MQlib. One of them is called IMQ jar. It's a specific implementation by OpenMQ of Java messaging service, and standard JMS jar with all these classes: queue, connection, connection factory, and so on. So you will need to add those classes over here. And JDK, you had over here the JDK 1.6 in the project that you imported, right? I would remove this library, if I were you, of course. And then I would add another library, whatever is the system library on your machine. I assume it's at least 1.7 or maybe even 1.8. So this is what you need to do. Done. This part is done. Message sender. And all this you have in the second slide, I would assume, right? So it says look at the message sender code, but basically it was on the slide. Start message receiver, and then start for message sender. Let's do it. So message sender, exactly what we had on the slide. Create connection to this OpenMQ with these passwords, and you're sending a message with this content: IBM 200 market. This is what we are sending. This is one program. Then it is going to print successfully placed an order to purchase 200 shares of IBM. And after that, you have all these connection clauses in the finally clause. Again, in JMS 2.0, you don't need to do this. Message receiver, it's a different program. They don't have to be started at the same time. Again, it's asynchronous. It's loosely coupled. But still, it connects to the same messaging server. It connects to the same queue. It's going to be listening to the same queue, right? And it starts listening. Over here, on purpose, I put it to sleep for 100 seconds, right? So this program won't finish immediately. At least it'll be up and running, listening to the queue. This class implements message listener. Hence, you have onMessage callback. So the onMessage callback will be called when the message sender will place a message in the queue. So let's start. Let's start this program, message receiver. Right click, run as Java application. The message started listening to the queue. See, nothing is happening because the queue is empty. Now I'm going to start. Actually, you know what? I'm going to open a second console. Open a new console. I want to have this is message receiver for now. Actually, let me start the sender. The sender will send the message into the queue and the receiver will immediately pick it up. This is a console for the receiver. It's printed it. It selected the 200 shares of IBM. It picked up. And this is the console for the sender, right? The console for the sender. I have two consoles. One is for the... Actually, I need to just show different console in different window. This one is for receiver. Receiver received it. It's still up and running. See, it's not even 100 seconds. But the sender already gone. Let me run again the sender. Another message I will put there. Run as another message placed. Let me see the second console. See, it received already two messages. So these two program works. They are both working with the same test queue and they work fine. This was our walkthrough. That's the only walkthrough that we have for today. And a couple of words about Java EE 7. It includes JMS 2.0 and it has a class JMS context that encapsulates the functionality of both connection and session. So you have less steps, and this API is called simplified API, they call it. It's well documented, so it's pretty simple to learn. And it has JMS producer and consumer, and exception is not required anymore. It's replaced with runtime exception, which is not checked exception, so you don't have to catch it. And we are close to the end. I want to show you one thing. MOM server. It's a standalone server that can be up and running by any vendor server. External MOM client, this is what we did today. We didn't use JNDI server. This external program was pushing messages to the MOM server, and another client was retrieving messages from there. This gray oval, it's my representation of a Java EE server. Java EE server. So if you start Java EE server, it brings up JNDI tree. If in that JNDI tree you would configure messaging object, say a queue, I could create a name on JNDI server that would point at the JMS queue. JMS queue that would point at the test queue that I created in OpenMQ server. If I would do that, then the program running inside the server could use injection or lookup. The external program could do a lookup in JNDI server, finding an object known as whatever name we give, but they would actually point at the MOM server. This design gives us the flexibility. Why? Because if we decide to change vendor of MOM server to a different provider, then it would be pretty easy. We would change the vendor and we would recreate new vendors objects under maybe the same names under the JNDI tree. So the external or internal clients of messaging would not even need to change. And configuring resources with Glassfish, it's pretty simple. You would need to go to, if we would want to do this, you would go to the admin console and port 4848. Let me see where is that. Different screen. Localhost 4848. It's admin Oh, I didn't even start the Glassfish. See, I was running all that and the Glassfish wasn't even running. Let me start Glassfish. I just want to show you the moment. I will not be actually configuring any JNDI objects, but at least you will know where to go. So it's up and running. Now let me refresh this console. Glassfish server. Again, remember, at this point we have OpenMQ messaging server listening on port 76 and 77, and the Glassfish is running on port 8080. The console is using port 4848 just to show what's the content of these objects. See, they have a node called JNDI tree for any JNDI object. I don't know why they created this layout, but JMS resources, they also belong to JNDI actually. They are all JNDI objects. So in JMS resources, say if you wanted to configure destination, a queue, right? At this point, Glassfish has no idea that there is somewhere this OpenMQ server with configured test queue object. But what you could have done, you could have said new, give it a name, any name you want, JNDI name. Physical destination name, you would need to give the one that you are mapping to, right? In OpenMQ it was test queue. You would need to specify if it's a queue or a topic and so on. So basically you can create a mapping in a JNDI tree to a physical queue on a particular provider. After that, you'd be either doing lookup over here or resource injection. And what else? It's another slide that I took from Oracle's Java E7 tutorial. Here's a link. I encourage you to go there and read about it. But the point is the same. Admin tool binds the resources to JNDI in space, and then JMS client, whatever program you write, will either do a lookup or inject a resource, and then you are connecting to messaging server. That's about it, guys, for today. Brief, I know, but sorry, it's introduction. Homework, lesson 30-31, try it section, and you're good to go. Thank you very much for listening. Lesson number 16. We have two more to go in this series, and my name is Yakov Fein. I am from Farata Systems. Thank you very much for watching.